Hello rocket minds, welcome back to physics class. So let us blast off into the world of motion and explore how speed and acceleration changes with time through the velocity time graph and acceleration time graph. So here we begin with the velocity time graph and acceleration time graph. Moving ahead, children, we know that the rate of change of velocity is defined as acceleration, whereas the rate of change of displacement is defined as velocity. Acceleration means the rate of change of velocity. That is simple. In simple, acceleration equals to velocity by time and velocity equals to displacement by time. This means velocity divided by time. So this indicates the slope. Velocity by time indicates the slope. Okay. Tan theta, slope. So the slope of velocity time graph always gives acceleration. Since acceleration equals to velocity by time, the slope of velocity time graph gives acceleration. Remember this, children. Similarly, we know that the rate of change of displacement is velocity, or displacement can be written as velocity into time. That means the product of velocity and time gives you displacement. Okay. So this is division factor and this is product factor. So whenever we consider this product, then the area under this velocity time graph gives displacement. Product is considered means area we have to concentrate. Factor, ratio is given. Okay, then slope, that we have to consider. Okay, this is slope and this is area. That we need to remember, children. So let us try to apply the same knowledge through the graphs. Moving ahead, the velocity time graph. Children, look at the first graph, children. And before starting with, I also would like to tell you that whenever you plot a graph while taking velocity and time, velocity must always be considered on the y-axis and time is always taken on the x-axis. I repeat, the velocity must always be considered on the y-axis and time must always be taken on the x-axis. So, in the first example, first graph, if you focus on, so this represents the velocity time graph. Okay, so if you observe the same figure, the velocity time graph is drawn parallel to the x-axis. We know that this is an x-axis and here is a y-axis. So this graph, this line indicates, this PQ line indicates the velocity time graph. Okay, so this PQ line, that means velocity time graph, is drawn parallel to the x-axis or parallel to the time axis. So this is your first consider. So I have given an example based on that. So I have plotted the time as 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds and so on. And on the y-axis, 0 meter per second. Velocity is measured in meter per second, whereas time is measured in seconds. Okay, so 5 meter per second, 10 meter per second, 15 meter per second, 20 meter per second and so on. So if you observe the same graph, then the graph is parallel to the x-axis. Graph is found parallel to the x-axis. So whenever there is no slanting position, so simple parallel means then the slope of the graph is 0. Slope of the graph is 0. So as I said that the slope of velocity time graph is acceleration. Since there is no slope, okay, no slanting position, no angle, no tan theta, okay, theta equals to 0. Hence we have acceleration is also 0. Okay. So children, since it is a parallel to x-axis, if it is drawn something like this means some angle it is there, some slope we can measure. Okay, but here there is no slope. Since slope equals to 0, it implies that acceleration is also 0. Is that clear, children? Okay. So in the above graph, the body moves with the constant. No acceleration means it has uniform or constant velocity. Okay. And how much velocity? We observe that after 1 second also the body maintains At 0 second, the body has 20 meter per second of velocity. After 1 second, the body still maintains 20 meter per second. After 2 seconds, the body still have 20 meter per second. After 3 seconds, 20 meter per second. And even after 4 seconds, the body maintains the same velocity, that is 20 meter per second. So that means we observe that after every fraction of seconds, the body has the same constant velocity. Hence, we can conclude that the body moves with uniform velocity. And how much is the velocity? The body has uniform velocity of how much? Every time it maintains 20 meter per second. The speed of the body, that is the velocity of the body, was found to be 20 meter per second. Since slope equals to 0, we can also conclude that acceleration of the body is 0. Uniform velocity means, constant velocity means its velocity is neither increasing or neither decreasing. So the acceleration, not at all acceleration, hence acceleration is 0. Is that point clear, children? Okay, now moving to the next one, that is case 2. So acceleration is 0 and the body moves with uniform velocity. Now coming to the displacement. As I said that the area under the velocity time graph gives displacement. So here we go with so this is your velocity time graph. Under this velocity time graph, this portion is totally covers your area. This complete region indicates your area. So what is the area of this complete picture, children? This area, if you could calculate the area of this under this graph, this will give you the displacement. Okay. So what is the area of the graph? I told you that area is nothing but area under the velocity time graph is velocity into time. Okay. So what is the velocity under this graph? What is the velocity that is being carried on? 20 meter per second. Hence, we have the value of area as velocity into time. Velocity into time. So, what is the velocity? This velocity was found to be 20 meter per second, and its time, how long its velocity been maintained? Until 4 seconds. So 4 seconds. Then 20 meter per second into 4 seconds. How much is that, children? 20 into 4 is 80. So 80 meters. So what is the total displacement of the body? The total displacement of the body is found to be 20 meters. Is that clear, children? Okay. So whenever the graph represents a velocity, whenever the velocity time graph is drawn parallel to the time axis, then parallel means acceleration is 0. Parallel means slope is 0. So slope 0 means acceleration is 0. Whereas the complete area under this velocity time graph, whatever the area, the portion is being covered, that gives your displacement. And in this example, the displacement, so area is nothing but your displacement. Area under the graph gives displacement. Hence, the area of this example has found to be 80 meter. Okay. So the displacement of the body was 80 meters. Clear, children? Now let us go with the second example. So in the second case, what we considered is the velocity time graph. This is your velocity time graph, and this velocity time graph is not parallel to time axis. Here, first example, velocity time graph is drawn parallel to time axis. Second example, velocity time graph is not parallel to time axis. So not parallel means some slanting position is there, some angle is being formed. Yes or no, children? Some angle is being formed with respect to time axis. That means some slope is there. So let us see what happens when slope is there. Recently we have told that the slope of velocity time graph gives acceleration. Okay, children? So the slope is nothing but velocity by time. So here some velocity you could observe. Okay, so some velocity, let me take it as v and here 0 and some time as t. Okay, in this case, as it is having certain slope and at time t equals to 0, at time t equals to 0, the velocity was also found to be 0. Okay, that means the body starts from rest. At starting time t equals to 0, the velocity of body was also 0. That means the body starts from rest. And as the time increases, the velocity also gradually increases. So that means the velocity time graph moves away from the velocity and time axis. So it moves away from the velocity axis. It also moves away from the time axis. So the slope is non-zero. So some slope is there. That means some acceleration is there. And this acceleration, how is this acceleration? As time increases, velocity also increases gradually. Hence, the acceleration is uniform. Acceleration is uniform. And as the time increases, we observe that velocity also increases gradually. Okay, children? So, velocity increases at uniform rate and hence we can say that acceleration is uniform. This body is having uniform acceleration. And velocity is increasing. Increasing symbol, I am simply writing this. Here the velocity is increasing at a constant rate and hence the body has uniform acceleration and the body starts from rest condition. Whereas the area under the graph, what is the area under the graph, children? The area under the graph is given as this portion. Okay, so since this is your graph, the area under the graph covers this portion. So this area under velocity time graph always gives displacement. So if the values were given, you can, this shows an example of a right angle triangle. So formula for right angle triangle, area of that half base into height, like that we can calculate the displacement. So let us try to solve the numericals in the later sessions. Okay. So here it's very clear that at time t equals to 0, velocity is 0. Hence, the body starts from rest. But in the second example, if you observe, at time t equals to 0, the body has certain velocity. That means here the body does not start from rest. Already the body starts from some initial velocity and moves uniformly at constant rate. That means uniform acceleration, and its velocity changes to some other value. So here in this case, initial velocity is also there, final velocity is also there. And the area under this graph, the total graph, this trapezium shape, whatever is there. So this area under the graph gives your displacement. So what makes the difference means whenever the body starts from rest, you have a displacement in the shape of a triangle. But whenever the displacement whenever the body does not starts from rest, whenever the body starts from some initial velocity, then in order to calculate the displacement, you have to calculate the area of that trapezium. Is that clear, children? Okay, so moving ahead with the next concept, the same velocity time graph. So this we can observe some zigzag motion. In this case, we have the positive velocities as well as negative velocities. Okay, we know that, so velocity is increasing, velocity may be increasing or velocity may be decreasing. Okay, so velocity, increasing velocity and decreasing velocity is plotted in the above graph. Okay, so based on that, if you would like to calculate the acceleration, so acceleration, every position acceleration is taken as the slope of that particular point. And if you want to find the displacement, or if you would like to find the distance, so one more thing I would like to add upon, children, if you would like to find out the distance, okay, here if you consider the distance is equals to distance and displacement. I would like to make you clear regarding the distance and displacement. This triangular portion, let me call it as area 1. This triangular portion A2, and here this trapezium portion A3. If you take distance, you know that is always positive, okay? The magnitude, whether it is positive value you get or in the negative value you get, you must always consider the magnitude of that. Magnitude means only positive area. Again, positive area 2 and positive area 3, this total value gives the distance of that body. Distance covered by the body. But if you would like to find out the displacement of the body, then displacement can be 0, positive or negative. So no need to consider the positive values, no need to consider the magnitude. Simply add upon whatever the areas are there according to the signs. Okay, so if it here you have A1 means in this case you have positive plus A1 you have, and here A2 means negative A2 you will be getting. In this case what you will be getting, children? Negative A2, and here again upper case means positive A3, like that. Based on the symbolic notations we have whatever we get, based on that we have to calculate the area under the graph. Displacement means both the positive and negative values will take up. Distance means the same area, but you must always consider the positive values. Is that clear, children? Okay. So similarly, one more example was given. In this example, we have initial velocity and final velocity. Some initial time and some final time was also given. Okay. So the slope of this graph, slope here means is nothing but theta is given, means tan theta. So in this example, if you consider, the slope of the graph is taken as tan theta. So acceleration is nothing but slope of the graph. Slope of the graph either can be found as tan theta or the change in velocity. Here the initial velocity, here it has started its journey. So initial velocity was found to be V1 and final velocity. In this case, velocity was V1 and final velocity from here to here, final velocity is taken as V2. So what is the change in velocity? V2 minus V1 upon, and what is the time? Here it has started its journey at T1 time and its journey ended at T2 time. So T2 minus T1. So either the slope of the graph gives acceleration or the change in velocity upon time gives your acceleration. So like that we can calculate the acceleration. Similarly, if you would like to find out the displacement of the given body, you have to calculate the area under the graph. Is that okay, children? Well, and one more thing I would like to tell you, children. Suppose if the velocity time graph, it happens to be curved like structure. Earlier whatever I have discussed, everything in the either parallel to the x-axis or not parallel to the x-axis, but in they are always in the straight line motion. Okay, straight line motion means acceleration may be uniform or 0. But whenever the graph is curved, okay, the curve may be uppercase or the lowercase. So you like this parabolic shape or hyperbolic shape. So in this case, we found that as time increases, velocity increases gradually. So velocity is increasing gradually. Whereas in this case, as time increases, here also what we observe is velocity changes with respect to time. So two curves are possible. Okay, children, but what makes the difference is means the velocity time graph whenever it is a curve. So no doubt here also velocity is variable, here also velocity is variable. Okay, children. So based on that we can conclude that the curves of the graph, if you observe, means the velocity is also variable as usual, but one more thing is that acceleration also changes with respect to time. Earlier cases, the acceleration was uniform. Whenever we get a straight line means the acceleration is found to be uniform. But curved like structure means acceleration is variable. That only makes the difference. Earlier case, velocity is variable. This case, velocity is variable. But earlier case, acceleration is constant. But here acceleration is variable. That thing you need to remember, children. And now moving to the next topic, that is acceleration time graph. The same case, children. So acceleration time graph, if you plot a graph, here we observe that the acceleration time graph coincides with the time axis. This bold line, this acceleration time graph coincides with the time axis. That means here the acceleration, as time increases, the acceleration is 0. So acceleration after any time, if you consider 1 second, 2 second, 3 second, 4 second, 5 seconds, any time if you consider, the acceleration every case found to be 0. So it's not accelerating, the body is moving with uniform velocity. Whenever acceleration is 0, the body found to be moving with uniform velocity. So whenever acceleration time graph coincides with time axis, acceleration is 0. Here what I gave you in the previous example was, when was acceleration 0? When this is an example of velocity time graph. Okay, velocity time graph parallel to time axis, acceleration is 0. In this case, acceleration time graph coincides with the time axis, acceleration is 0. Next, one more example. Acceleration time graph parallel to time axis. That means here, if this happens to be 0, means here we have certain acceleration. Let us suppose some example as something like 5 meter per second square, 10 meter per second square, 15 meter per second square, 20 meter per second square. So everywhere the acceleration remains constant. How much value? Every time, after every time interval, if you observe that, the acceleration remains constant. That means the body moves with uniform acceleration or constant acceleration. The acceleration time graph parallel to time axis means the body moves with uniform acceleration. Is that clear, children? Now, the last example for the same acceleration time graph. Here we can observe that this acceleration time graph is moving away from the time axis as well as away from the acceleration axis. Okay, so this type of example we can say that as time changes, as time increases, acceleration also increases. Acceleration is also changing. So this was an example of a constant acceleration. So this is an example of a variable acceleration. Okay, children. So maybe the concept is clear to you, but unless and until we solve few numericals, that means with the help of only applications, we can grasp the concept very well. Okay, children. So this is an example of zero acceleration. This is an example of uniform acceleration. This is an example of variable acceleration. I also told you that the area under this acceleration time graph, this area, the complete area under acceleration time graph, what does that give, children? This total area gives to be, because area, children, we know that acceleration equals to velocity by time. This implies velocity is equals to acceleration into time. That means if you multiply acceleration with the time, you get velocity. That means the area under acceleration time graph gives velocity. The area under acceleration time graph gives velocity. Whereas the area under velocity time graph gives displacement. The area under velocity time graph gives displacement and the area under acceleration time graph gives velocity. Why? Because acceleration into time gives velocity and velocity into time gives displacement. Like also, the slope of velocity time graph gives acceleration. And the previous example in concept number 9, we have discussed displacement time graph. There we discussed that the slope of displacement time graph gives velocity, because velocity equals to displacement by time. Okay, so slope of displacement time graph gives velocity. So similarly, the slope of velocity time graph gives acceleration. So these 5 things you need to remember carefully, children. Okay. So based on that, let us try to solve few numericals from worksheet number 10. So this is the given figure. The velocity v versus t graph of a body is a straight line. Not okay, of course, straight lines and up and down motions as shown in the figure. You're asked to find the displacement of the body in the first 5 seconds. But before starting with, let us recall back with the concept. What we know was, so we know that velocity equals to displacement by time and acceleration is equals to velocity by time. Whenever this fraction ratio we observe that, this indicates the slope. That means slope of displacement time graph gives velocity and slope of velocity time graph gives acceleration. Similarly, we also know that acceleration into time gives velocity. Yes or no, children? So from this we can see that velocity equals to acceleration into time. And here we can say the displacement equals to velocity into time. So the area under velocity time graph gives displacement and area under acceleration time graph gives velocity. These 4 things if you get inside your mind, you can solve all numericals in a proper way. Okay, so here what you're asked to find out? You're asked to find out the displacement. So where is the displacement? Here. So in order to find the displacement, you need to find the area of velocity time graph. So this is the velocity. This is given as velocity graph, and here it is given as time axis. So area means here you have triangular portion, here you too have triangular, triangle. But what I said means displacement means upper portions are taken as positive and lower portions are taken as negative. So based on that, let us try to find out the displacement. Okay, so displacement S, total displacement S, okay, equals to, so this one let me represent as area 1, area 2, area 3 and area 4. Without taking magnitudes, you have to calculate all the areas, 4 areas. What is the area of the first figure, children? That is half triangular portion. This triangular portion, if you want measure, means this triangular portion is, formula for it is a right angle triangle, half base into height. What is the value of base, children? From here to here, how much? 2 seconds into height. What is the height? From here to here, it is found to be 2 meter per second. Okay, time, this height is taken on velocity axis, height of the triangle. Okay, this is measured in velocities, that is half base into height, half 2 into, this is 2, half 2 into 2, first area. Moving to the second area. The second area means this triangular portion, this part. Okay, so what is that, children? The value was found to be how much again? That is also triangle, half from here to here. What is the length? 3 minus 2. 2 to 3 is 1 second. So 1, again height for the same triangle, the same value, that is 2 plus area 3, this portion. This portion means you have to take minus down, no, lowercase, minus half base. Base of this triangle is what, children? This region, this area. So from here to here, this is the base of the triangle, that is 3 to 4 means 1 second. So that is 1 into height of this triangle. From here to here it is 2. Because I already took consider minus here, no need to keep again minus 2. Simply 2 plus this value, the final value, that is area 4. It is in the rectangular portion or square portion. Area of a rectangle is base into height, length into breadth. What is the length from 4 to 5? It is 1 into height from 0 to 1, it is 1. So if you simplify this, you will get the total displacement of the particles. So children, solve this. 2 gets cancelled, here also 2 gets cancelled, here also 2 gets cancelled. You are left with 1, sorry, this is 2, 1 into 2 is 2 plus 1 minus 1 plus 1. This 1 and this 1 gets cancelled. 2 plus 1 is found to be 3 meters. And hence, option number 2 is your answer. Is that clear, children? Okay. So the upper areas are taken as considered as positive, lower areas are considered as negative. So simplify that, children, you'll get the answer. Okay, so the displacement is found to be 3 meters because displacement equals to this area, velocity into time. Over. So moving to the next question. A body thrown vertically upwards, which of the following graph represents the velocity of the body with time? Children, whenever the body is thrown upwards, what happens? Its velocity goes on decreasing, and finally after reaching certain height, maximum height, its velocity becomes 0. Later on, what happens? The body falls downwards. The body falls downwards means again what happens? From 0 velocity, it gains certain velocity as and when it reaches downwards. Okay, so everything was explained in the previous concepts. Okay, we have solved few numericals also based on that. So we have given some velocity to make a body. Whenever the body is thrown upwards, we will be providing some velocity. So it has some maximum velocity. With that velocity, the body goes upwards. Gradually its velocity decreases, and finally after reaching maximum height, its velocity becomes 0. Again the body falls downwards. Okay, and from 0 again it starts increasing in velocity and again reaches ground. Okay, that means first the velocity decreases and later the velocity increases. Now let us try to understand the graphs properly. In this case, we observe that as time increases, the velocity decreases. Yes, as time increases, first initial what happens? The velocity decreases, and later on what happens? Again the time increases means after reaching certain height, the velocity again starts increasing. Okay, so you people generally get confused means by plotting a graph like this. You will be taking velocity here, time graph here. Velocity increases means like this. Velocity decreases means like this. Don't get confused. Decreasing velocity, time passes on, velocity is decreasing. Time passes on, velocity is increasing. Is that okay? So increasing velocity and decreasing velocity. So clearly it is decreasing. So as the body moves upwards, the velocity decreases. So graph is clear. After certain time, when it reaches maximum height, what happens to its velocity? 0. Later on again what happens? Its velocity starts increasing. Okay. Maybe yes, it seems to be true. It seems to be true. Let us see. Check with the other graphs and conclude with the perfect answer. If you go for the second one, what is given means here velocity is decreasing. Okay, and in this case, simultaneously, how at the same time does a body have a positive velocity as well as a negative velocity? This is plus v and here it is minus v. At the time t equals to 0, this is t equals to 0, body have the positive velocity and negative velocity simultaneously. How is it possible? So this is a contradictory. So not at all possible. At the same time, the body is having two different velocities. Not possible. Moving here. So here also at the same time. So if you consider this is 0 time means it's okay. Any other portion if you consider at the same time, the body may have two different velocities. At the same time, the body may have two different velocities is not possible. Again, try to understand this graph. Okay. So what happens means the velocity decreases gradually. As the time increases, velocity decreases gradually. As the time increases, velocity decreases gradually. Later on what happens? The velocity starts increasing. Here also as time increases, the velocity gradually what is happening? It goes like this, like this, like this means it is also increasing in the reverse direction because plus v and here minus v in the opposite direction. This is positive direction, this is negative direction. So which seems to be true? This graph or this graph? The body moves upwards and again falls downwards. The direction has changed. Yes or no? Earlier it is moving in the positive direction. Upward motion is taken as positive direction. Downward motion if you consider as the opposite direction. Okay, negative direction. Then which graph is true? This is an appropriate graph because the direction also changes. Suppose there are some cases if no direction changes means then you can opt for this figure. So now the only correct answer is fourth option because its direction changes in the opposite case. But here both in the positive cases only. This may happen. How means body goes on, velocity becomes 0. again increasing in the same direction means you have to take this. In the opposite direction means you have to consider this. So no doubt, fourth option is true. Okay, children?